In our last video, we showed you how a student solved 12 plus 8 plus 4. But what does that actually mean mathematically? Let me show you how to perform addition on the Linear Abacus and explain what you're actually teaching and why this matters. So first, let's be clear about what addition actually is. When we look at this number sentence here, 12 plus 8 plus 4, all of these numerals are actually acting as actions first before they become numbers, which are totals or places in an order. So when we see plus 12, that's not a number yet, it's an action. And we're counting on from 0. We start here at 0 and then we count on 12. And watch how the structure helps. 1 full row of 10 plus 2 individual beads. Now I can see why this is 12. So now we're sitting on 12 and we need to add on 8 more. I can use the structure of the beads here to help me. I know that each row has 10 beads. If I've used 2 beads here to make the 12, that means there are 8 left over. And all I need to do is slide the rest of this row across. And instantly I can see that at this point I'm up to 20. Now to finish the addition, I just have to add 4 more beads. Looking at the total, or looking at the position of this last bead, I can see that the answer is 24. But here's where it gets interesting. Addition has this property that's called the associative property. This means I don't always have to work left to right. I can choose which numbers to combine first. So what happens if I start with 8 plus 4 first? Let's take a look. 8 plus 4, we can break this up to make it even easier. I can break the 4 into 2 and 2. And so now I can see that I make 10 first, 8 plus 2, and then I add 2 more, which is 12. Now my problem becomes 12 plus 12, which is much easier to work with. So how do we solve 12 plus 12? Well, we could use place value. And what that means is I break up the numbers into groups of 10 and 1. Now, automatically on the string, you can see that 12 is made up of one group of 10 and 2 ones. So that means I've got 2 lots of 10 here and I've got 4 ones. So I can get to the answer this way and quite quickly. Or I can use a second strategy where I build up. So if I'm starting with the first 12 and I still want to split the group up into 10s and 1s, then I need to slide a 10. And to do that, I need to grab 2 more of the blue beads from the third row, which I can see immediately gets me to 22. And then I add just 2 more beads, which means I get to 24. So you can see I get the same answer, even though I'm using different thinking, but both are valid. Now here's what concerns me about traditional teaching. Most children at this age often know one strategy, and that's usually a count by ones using their fingers. They get lost, they make errors, or they lose confidence in this process. But when we use the Linear Abacus, children start to see patterns. They notice the number bonds, like the make 10, and more importantly, they realize that there are more efficient ways to think. This transformation doesn't happen overnight. Most of our teachers spend 1 to 2 weeks on each game because it allows for this natural progression to occur. But watching children move from counting by ones to reasoning flexibly with numbers, it's quite a beautiful journey to witness. I hope this helps you understand how young children can learn to reason with models and not just memorize procedures.